This lesson is to go over some homework problems on lesson 106. Number 10, it says copy the segments onto a sheet of paper. We call A and C. And how can we construct isosceles triangle? So the hint here is draw a circle with the radius of AC. So isosceles triangle is the triangle with two equilateral legs. So the equilateral triangle has to have a two equilateral triangle. No. Isosceles triangle has to have two equilateral sides. The third one doesn't have to be exactly the same as the other two. So here is the hint for problem number 10. Can you actually draw the same equilateral segment to AC with AC? So that's the question here. That's actually a hint here. Problem number 11. Use a compass to construct two circles such that one circle has a radius that is the same length as the diameter of the other circle. That means you have a circle and there's another small circle that is exact with that diameter is exactly the same as the radius of the big circle. How do you draw this or draw this? And problem number 12, construct the quadrilateral with at least 160 degrees angle and all sides that are the same lengths. So this means that it says all sides that are the same lengths. That means it's rhombus, right? Because the rhombus is the parallelogram that has exactly the same lengths. And the one has to be at least 60 degrees. It says construct, so you got to use the compasses and all that. If you need it, come to my class. Number 13. Draw several different triangles. For each triangle, construct a circle that passes through all three vertices. For what kind of triangle is the circle's center in the following location? Inside the triangle, on the triangle, outside the triangle. So this is what it means. So let's say we have some triangle like this. This is what's called the obtuse triangle, and then you're going to draw a circle that passes through those things. So it's going to be like really big one, if you know what I mean. The center will be somewhere over here. So the question here is, what kind of? So this is obtuse triangle. So that should fit C, which is outside the triangle, because center of this circle is actually outside of this triangle. Does it make sense? So maybe if you use different kind of triangle, for example, what's going to happen if you have acute triangles? If you draw a circle, where would the center be? Would that be on the line, or would that be on inside of the triangle, or would that be outside the triangle? So that's what the question is asking. Number 14. Standardized test prep. Mr. Mendoza's geometry class came up with 4 conjectures about the medians and the altitude of the triangles. Which of the following conjectures is not correct? So just to go over some words, the median is the line that is from one vertex to opposite midpoints. That's the median. Okay, that's the median. Midline is the line that connects midpoints of two sides. And altitude is if you draw a perpendicular line from that passes through one vertex and going through the opposite side. That's the altitude. In many middle school classes, they call that a height. So if you have obtuse triangle like this, the altitude will be outside. You have to measure it outside a triangle. So that's a perpendicular line. So which conjecture is not correct, is false. A median of a triangle divides the triangle into two smaller triangles of equal area. Is that true or false? So those are the problem. Go through A, B, C, D and see if which one's wrong. Salim planted 3 new saplings. He wants to install a rotating sprinkler to water the 3 saplings. Where should he install the sprinkler to make sure that all 3 saplings get the same amount of water? A. Trace the sapling onto your paper. So you're gonna trace these saplings onto your paper. And then B, you do show where Salim should install the sprinkler so that all the saplings will get equal amount of water. And then you explain why. So you've got 3 saplings, which I'm assuming it's 3. Where should we put the sprinkler? Should we put the sprinkler right here? Or 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 right here? Where is that? That's the question. Number 16. To reflect the points over a line, do the following. Construct a perpendicular line from the given point A to the given line L. So we've got line L, and we call the line L, and then we've got A right here. And how would you draw perpendicular line passing through this A to this line? So maybe something like this. It has to be 90 degrees. You have to intersect 90 degrees. Now, how would you do that? We've learned that actually, how to do those. And also, you don't need any tools, but you gotta fold the paper. That's the biggest hint I can give you. 2, on the perpendicular mark points A prime on the other side of L from A so that A prime and A are the same distance. So you should have that A prime so that the distance from, let's call the intersection point M to A prime and M to A will be exactly the same lengths. Part A says on your own, draw a point and then draw a line that does not pass through the points. And B says follow the direction above to reflect the points over the line. Think of the line as a mirror. In the figure above, A prime is the reflection of A in the mirror, and N and A prime are the same distance from and in the same position relative to the mirror. Okay, so just follow those things, and that's lesson 1.6.